Hello, this is my first video, and in this video we will talk about the differential equations, the classifying of differential equation, the ODE and PDE, linearity, and order of differential equations. So what is a differential equation? A differential equation is a mathematical equation that relates some function with its derivatives. So as I write, an equation involving derivatives of one or more dependent variables with respect to one or more independent variables is called a differential equation. We use differential equations in lots of areas, physics, engineering, maths, biology, economy, etc. So, for example, if you look at the Newton's second law, I guess you all know the Newton's second law, the force is equal to mass times acceleration. I say the position is ut. So if you take the first derivative of position with respect to time, it gives us velocity, and second derivative of position with respect to time gives us acceleration. So in this differential equation we have independent variable and dependent variable. So what is independent variable and dependent variable? For example, dy over dx is equal to first derivative of y with respect to x, and it means that x independent variable in here and y dependent variable. So in here s and t are independent variable, z is dependent variable, and here and t independent variable, and x is dependent variable. So it's very easy, I guess. X and t independent variable in here, and u is dependent variable. So let's look at ODE and PDE. What is ODE and PDE? ODE is ordinary differential equation and PDE is partial differential equation. It means that ordinary differential equation is our equation is respect to one independent variable, and partial differential equation, the function is depends with two or more independent variables. So in here 1 and 3 are ordinary differential equation because its independent variable is related to one independent variable, and 2 and 4 are partial differential equations because in here the function is relates with two or more independent variables in here. So let's look at for order. The order of the highest order derivative gives us the order of the differential equation. So in here highest order derivative is 7, the seventh order of y with respect to x, but this is this gives us degree. It's not same thing with this, and this means that the first derivative of y with respect to x to the 8, and this is 7th order ordinary differential equation, so it's this is one independent variable already. And let's look the second example, and this is 3rd order. The highest derivative of order is 3, and it relates with two independent variables because it's partial differential equation. So let's look at the first page again. In here, this is 2nd order differential equation because the highest order derivative is 2. This is not order of derivative, this is degree. This is 1st order, this is 4th order, and this is 2nd order. So let's look at the linearity. So linearity, this is the general solution, rule of linearity, and I guess this is a bit complicated. So let's look at here. Linearity is simply like this. So linearity is have three rules. The one dependent variable y and its derivatives occur to the first degree only. So look at these three equations. These are all first degree. There is no products of y and its derivatives. So it means that there is no y times y prime, or y prime times y prime times double y prime, whatever. This is all the products of y. And if you look at the third, all of three equations, that we see that there is no products of y and its derivatives. We say that in y because y prime is equal to dy over dx, and the dependent variable is y in here. So don't learn it like that. Don't learn it. It's writing y in here. Y is dependent variable because we writing y in here. There is no transcendental function, exponential, logarithmic, and trigonometric function of y and or its derivative, or there is no transcendental function of dependent variable and or its derivatives. However, let's look at the examples. This is sixth order linear ODE, because we got satisfy all of these three rules. This is dependent variable, and there is no products of dependent variable. This equation is first degree, and there is no exponential, transcendental function, logarithmic, or trigonometric function of y of dependent variable. So it's linear ODE. So let's look at second. This is fifth order. I guess you see it. This is fifth order linear ODE. There is no products of u. And this is first degree, and there is no transcendental function of u, the dependent variable. Let's look at third. This is second order linear ODE. There is a transcendental function of sine, but sine theta. Theta is independent variable, so it's not affects the linearity. This is already linear ODE. Let's go for this is seventh order non-linear ODE, because there's this is not first order. The function is not first order, so this is non-linear ODE. So let's look at this. This y prime is equals to dy over dx. I guess you know it. This is first order non-linear ODE, because there's a product with y. You can in linear ODE in here there is no products of y and or its derivatives in here, so you can multiply by y and y prime, and it affects linearity, so it's non-linear. So look at last one. This is third order non-linear ODE, because there is again a product of y and y prime. So I guess we talk about on linearity and order and partial and ordinary differential equation in this lesson. So please subscribe.